Thank you for joining us for today's webinar. Today we are presenting a SuperMap mini classroom with the theme of election map making using SuperMap iDesktop. Let me introduce my name first. My name is Vela and I will be the host for today's sessions. And just a little reminder to you, if you have any questions during the presentations, please type them into the question box in your Zoom control panel. And now, without further ado, we will turn the time over to our presenter today, Firdausi Zahara Gandes, as SuperMap instructor. So please, Ms. Gandes, the time is all yours.
Okay, thank you, Vela, for the introduction. So, good day, everyone. My name is Candice. I'm the SuperMap instructor, and today I would like to speak in the SuperMap mini classroom in the 4th edition to present about how to map the election map. Okay, but before that, I would like to give you a short introduction about SuperMap. Okay, yeah. So SuperMap was found in the Beijing in the 1997 by Dr. Erzun Zhong. And for approximately 23 years, we have helped humans in solving various problems, especially with GIS as the main foundation. And we have about more than 4,000 employees spreading in all around the world, more than 1,000 partners in coming from the more than 30 countries, and also 38 branch offices and subsidiaries. Okay, the next one is the 5 main key technologies of SuperMap GIS software. Let's start with the first one is the big data GIS. So we support to do the whole process of the big data, including streaming data, storage management, spatial analysis, and also the data visualization. The second one is artificial intelligence and GIS integration. So in the SuperMap, the AI technology mainly provides 3 functions: the GeoAI, AI for GIS, and also GIS for AI. The third one is the 3D GIS. So SuperMap developed its function leads to 3D modeling from 2009 by integrating some technology like data model, scene construction, spatial analysis, and also the software form. The fourth one is cross-platform. So SuperMap is not only able to be open in Windows operating system, but also in Linux. And the last one is cloud computing. So since 2013, SuperMap available to do GIS processing using cloud technology that allow you to do computing services, including servers, storage, databases, networking, software, analytics, and also intelligence over the internet. And today, this will be our topic for this webinar, the election map mapping using SuperMap iDesktop. Okay, let's start with the question, why? Why we need to map the election result? So this is how the data of the election look like. As you can see here, there are so many data, large data, and the data is in the form of the tabular. Even if the data is already contained of spatial information, the longitude and also the latitude information, but it's not visualized spatially yet. So today, we will try to visualize the data spatially using SuperMap iDesktop. And just for your short information, election maps are the simplest and most effective way to display election results. Okay, now let's discuss one of the real case. Let's take United USA as the example. During the election period, many television reports or related websites will use election maps to display the latest poll results and also election progress. Like one of the example, the election map. As you can see here, you can find information about the distribution of the voters in the USA, but this method is only try to visualize the distribution of the voters, the dominant voters in each area, in each city. But this method is not doesn't consider the difference in population distribution, and this method is treats the state or city as a homogeneous area and gives the corresponding color symbols after counting the results of the votes. Okay, more details is this map. In this map, one city with large area but less population will look like more dominant in contributing the total vote rather than the opposite condition. So for today, we will not only visualize the distribution of the election, but also add other parameters that are the population density, population distribution, and also area. And this one is how the result look like. So maybe it's not really clear, but let me show you more details. So in the election map, we will try to map the election information based on the number of election, population density, and also the distribution. And from the map, we can gain information including the distribution of the voters, but also it will be visualized in the range map with different color for each range, and then where the thicker the color, the greater the degree of the vote. Degree of the vote is difference number of voters between the two parties, the Democrats and also the Republicans. And for today, we will use USA as the case. So we will choose one of the city in the USA for to to create the election map. And how about the data? So for the data, first one is we need the Illinois boundary. So for today, we will try to map the election in the Illinois. Illinois is one of the county in the USA. And then we will use the population data. This is our raster data. We will use the population data 2060. And the last one is we will use the vote information, including the county name, the voters from the both parties, and also the total voters. And the data is in the form of points. And how about the software? Of course, we will use the SuperMap software. We will use the desktop version, SuperMap iDesktop, and we will use the latest version, the 10i SP1. If you haven't downloaded or installed the software yet, you can download in the link attached in the presentation. Or you can directly download the software in the SuperMap website. And this one is the data processing flow. It starts with add the election information to the county boundary data. So actually the basic idea is to extract the residential areas from the surface coverage data and then assign election data to the different residential areas with population density and areas as the weight. And last, we will calculate the degree of support for different political parties by resident units. And the last one is make maps. And this is more details. So we will extract the residential areas from the surface coverage data, assign the election data to the different residential areas with population density and area as the weight, calculate the degree of support, and the last one is make maps. So maybe it doesn't clear yet, but no problem. I will show you the one by one step after this. But before I move to the SuperMap iDesktop, I would like to give you short explanation first about how we can add the election information to county boundary data. Okay, so as you can see in the slide presentation, the left picture is the county boundary. And then this county boundary have no any information yet, only the boundary have no information. And after this, we will add the election information to the county boundary. How to achieve that? So we will use one of the function in the SuperMap iDesktop that called the dataset attributes update. So by using this function, we will assign value to the county boundary refer to the election points. In the dataset attribute update, first one, we need to input the data that provide information in the data with attributes offered. And in this case, in the first case, still since we will put information from the election points to the Illinois counties. So the data with attributes offered, it should be the election points. And the next one is target data. So target data, it means data that want to be updated, and we will put the county boundary, the Illinois boundary here. And this is one of the important things. In the parameter setting, there are the spatial relation and also how the method how to get the value. In the spatial relations, it is sensitive based on the data you are put in the dataset attributes of update. If you put the offered data point and the target data is polygon, it will be shown like this. But if you put the data attribute offered is a polygon and also the data in the target data is also polygon, the spatial relation will be different. It's based on uh, the 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 data form. And how to get the value is also there are some methods. We can just assign the value or do the mean calculation, sum calculation, um, define the maximum value or others. And in the field setting, there will be two kind of field, the source data field and also the target data field. So in the source data field is should be the field from the data with attributes offered, and in the target data field, it should be the data in the target data, the field in the target data. Okay. So for example, since we will assign the president election point information to the uh, county region, so by using this by using this operation, we will assign the value of the president election point, which is in the spatial relation contain with county region. So after that, we will get a new field in the county region with information referred to the election points. Okay, now I will show you how to achieve that using the SuperMap iDesktop. Okay, yeah, this is the illustration of SuperMap iDesktop. And here, as you can see here, I already opened my data source. The data source is the election data source, and it already stored some data, the land cover 2016, the president election point, and also the county region polygon. So I will share this data later. I will show you the link to download the data in the last presentation. And if you are not familiar yet to use the SuperMap, after you download the data, you can open the data source by right-clicking in the data sources and select the open file data source. But now I will not show you because I already opened my data source. And now let's start with overlay the county data set. You can directly drag the data set to the map. You can directly drag the county and also the president election data set to the map. Now there are two new layers in the layer manager. And after this, we will try to add new information in the county data set based on the president election points. But before that, I would like to show you the information, the attribute table for each data set. In the president election dataset, as you can see here, there are so many information, including the voters in 2012, 2016, and also others, the total voters, and also another information. But we will not assign all of this value to the county dataset, but only the voters in the 2016, the total voters, and also the county name. And in the county dataset, there are no information here, only the basic information that originally stored in the county dataset. Okay, now we can close the attribute table and go to the data. And in here, please choose the dataset attributes update. In the dataset attributes update, in data with attributes offered, it should be the president election point, and the target data is county region. In the spatial relation, we will use intersect. It should be give the same result if you select intersect within and contain. Okay, maybe I would like to show you more information about the spatial relation. Let me show you the slide. Wait. So there are some of spatial relation in GIS. Maybe some of you are already familiar with this. There are contain, within, intersect, cross, overlap, touch, intersect, and also others. And in the intersect, this spatial relation, as I told you before, will be different if we put, if we try to, for example, try to check the point contained to a polygon, or is it able to do the content analysis between point or polygon, point to line. It depends on the data. So not all of the data can do this analysis, can do this spatial relation. It's based on the form of the data. But for intersect, we can do all of the calculation for all of the form of data. We can do point intersect to point, point intersect to line, and also others. But it may different with other methods, something like that. Okay, this is for the spatial relation. Now let's go back to the SuperMap iDesktop. Okay, now in the spatial relation, we will use intersect instead. And in the field setting, we will choose the Democrats 2016. Okay, Democrats 2016, Republicans 2016, and then the county name. Oh, I'm sorry, I forgot to tell you in the target field, since in the county dataset it has no information in the field, so we can create the new field. If we choose the new field here, so it will automatically create new field in the county dataset with the name same as the source field. And then the Republicans, Democrats 2016, and one more thing is the total voters. This one. Okay, so for this time, we will try to assign value from the president election point that intersect with the county dataset. Okay, now let's click OK and wait until the process successfully completed. Now let's open the attribute table of the county dataset. And here, there are already new field, the county, Republicans, Democrats, voters, and also the total voters in the county dataset. Okay, next process is we will add another information that is the population distribution. Now we can directly track the land cover 2016 to the map. And okay, before we do the analysis, I would like to show you some information. So in the land cover data, there are so many kind of values stored in the data. So Since this is raster data, so every pixel has a different value, value or digital number. That's why you can find the different color for each pixel here. And the pixel size of this land cover data is 30 by 30 meters. In this land cover data, there are so many information, including open water, developed area, deciduous forest, and also others. And each information have a different value. And for this time, since we will try to retrieve information about the population density, so we will use the developed one that characterized with number 22, 23, and also 24. 22 for the developed area with low intensity, and we will define this as the low population density, and then 23 for the medium and 24 for the high intensity. Okay, now let's get back to the SuperMap iDesktop. Like this one. So as you can see here, there are different value 24, 21, 41, 82, and also others. But now we will try to create a new data set, a new raster data set that only contain pixel with number 22, 23, and also 24. How to achieve that? You can go to the data and please choose the algebraic operation. Okay, in the raster algebraic operation, we will do operation to create a new raster file with determined value. So how to achieve that? Let me show you. Okay, now first we will put con or con. Con means condition. Will try to put a condition sentence here that allow the raster algebraic operation only select pixel value 22, 23, and also 24. And then put the open brackets and select the land cover. We will choose land cover with value 22 or land cover with value 23 or land cover with value 24. And after the operation, this algebraic operation is select pixel with value 22, 23, or 24, we will assign the original value for each pixel. So we will put land cover again, and for pixel that are not has value 22, 23, and 24, we will assign 0 value. And then put the close brackets. And in the result data, you can change some information here. I will save it in the same data source like the others, but I will change the name into resident raster. And then click OK. And wait until the process finish. You can see in the task manager here, it's still 12%. So this is the function. While waiting the process, I would like to give you explanation again about the population density extraction. So by using this function, we will only try to create new. We will try to create new dataset, raster dataset that contain 22, 23, and also 24 pixel only. And after after the function is this selected number, and then we will assign its original number for them. But for other pixels that are not have value have this one value, we will assign 0 value for them. Okay, it should be completed after this. Okay, the process already successfully completed. And now in the under the election data source, here we have the resident raster data. We will minimize the task manager. Now let's take a look how the data look like. Okay, now we have a new data, the resident raster, that contain information only the pixel with number 22, 23, and also 24, and another will assign as the zero value. Since this pixel size is too precise, 30 by 30 meters, and in order to make our analysis faster in the future, so we will try to change the pixel size from the 30 meters to 100 meters. So we will do the resampling analysis. You can go to the data and then raster resampling. In the raster resampling, please select the resident raster. And now we will create the new one with name resident raster 100 because we will change the resolution into 100 meters by 100 meter. And here you're also able to change the resample method. You can choose nearest neighbor or bilinear or cubic based on your requirement. And then I will click OK. Okay, new data is already appear here under the election data source, the resident raster with pixel size 100 meters. Now let's take a look how it looks like. Okay, this one is now have pixel size 100 meters. Okay, now next process is since this data is still in the raster data. So in the SuperMap, you can see here the different symbol for each data, and this means raster data. And after this, we will do the calculation using vector data because the other data is in the form of vectors. So we need to convert this raster data into the vector data. You can go to the analysis, and this is the vector converter. Please select the raster to vector. In the raster to vector, in the data source of the source data, please select the data source that contain of the raster data we are going to convert. And in the data set, please select the resident raster with pixel size 100. And you're also able to change the name of your result. I will change it into resident R mean region because I will convert the resident raster data into region. And you're also able to do further setting here, like the grid setting or the tolerance, the image setting, and also others. But since this process takes a long time, so I will not click OK here because I already prepared the result data in the prepare data source, the resident R. Now I will put this file to the map. So this is how the resident vector data looks like. If we try to check the attribute information, This is the process load of the data. Okay, now let's take a look how the attribute table of the resident vector data looks like. You can browse the attribute table, and in the resident data set, it only have information about the value of each unit, that are 23, 22, 22, and also 24. And after this, and one more thing I would like to show you, if the data is, there are so many data here. It contains 328,000 data. And after this, we will try to intersect this data, this resident vector data, with the county data sets. By using this intersect method, we will achieve one new data set that have information, that can keep information from both of the data, both from the resident and also both from the county data set. Maybe let me show you how this process looks like. So we will use this overlay analysis. We will use the overlay analysis. One of the example of the overlay analysis is intersect, but also you can find another one such as clip, erase, or others. In the intersect analysis, we can keep information from both of the data, such as in the right picture. In the right picture, the result data is stored information from both of the data, from the first one and also from the second one. But if you use others such as clip is only store information from one of the data. So by using intersect, you can store information from all of the data that intersected in each other. Something like that. Okay, now let's go back to the iDesktop. How to intersect? You can go to the analysis and then overlay analysis. And here, please select the intersect. Okay, in the intersect, source data should be the resident data that already converted into a vector data, and then overlay data set is, sorry, it should be in the election data source, is a county data set. And here you can change the result setting. You can change the result into resident intersect. And we need to set the fields because we need to check some information that we are going to put in the new data set. So please check in the value box, county, Republicans voters, Democrats voters, and also the total voters. And then click OK. And after you set the result setting and also put the source and also overlay data set, please click OK. But I also already prepared the result because this process takes quite long, because as you know, there are so many data. It's more than 300,000 data. So it may take a long time. And since we have a limited times for today, so I just prepared the result. So we can click cancel here. And upon the result, the resident intersect, that is the result from intersection process between the county and also the resident vector data. Now drag it to the map. And I will delete the resident layer. Remove from the layer, but not delete it from the data source. Okay, I will remove this. Okay, now we already have a new data, the resident intersect, that is retrieved from the intersection process between the county boundary that store information about the voters, about the county name, and also the total voters in the Illinois city. And also we store information of the value in the from the resident data. Now let's take a look at the attribute table. In the attribute table of the resident intersect data, here we have the value information that characterize what kind of population density in that unit, and then the Democrats number, the Democrats voters, and then the name of the county, the Republicans voters, and also the total number of the voters in the city in the 2016. And please be informed that the Democrats and Republicans voters here is in the form of percent. So this means the total voters of Democrats in the first units here is 44% from the total voters, 44% from the 2,822, something like that. And it has the same number, about more than 300,000 data. And one unit means like this. This is one unit, not one pixel, but it combined from some pixel, because we already do the conversion from the raster data to the vector data, and each unit has information like this: the value, Democrats voters, and then the name, Republicans voters, and also the total number. Okay, let me show you in the. You can open the properties like this one. Like this one, this unit is, the value of this unit is 23. So 23 means that this unit is medium density, medium population density, and also it has the number of voters in the 2016, and then the number of Republicans voters, the total number information, and also since this unit intersected with this boundary, so it will store this county boundary in each unit. Okay, I will close another tab. Okay. Okay, now next process is we are trying to calculate the degree of voters. Now I will go back to my presentation and show you how to achieve that. So this is the function of the degree of vote. The degree of vote is calculated from some parameters, the total votes, and then the number, that is the different number between the Democrats proportion and Republicans proportion, that divide by 100, because yeah, you know, the data is still in the form of percentage, so we need to divide it by 100. And then this is the main function. Actually, common people normally use this function to calculate the degree of vote. Only try to find the different value between the Democrats and also Republicans, and then multiply it by the total votes. But for today, we will add another information, that is the population density and also the area weight, like this one. This is act as the weight function. So here there are two categories in this degree of vote function: the main function, the normal function, and also the weight function. Okay, in the main function, we already have the data. We have the total votes data, the proportion data, but we don't have the weight information yet. So we will calculate it after this. In the population density weight, this is our assumption to define the population density weight. In the previous process, we already create a new data set that store information about the population density that characterized with number 22, 23, and also 24. 22 means for the low density, 23 means for the middle one, and the 24 is the highest density. And after this, we will assign a weight for each category of the population density. For the low density, we will put 0.15 as the density weight because, as you know, low density is means that there are only a low of people in the units, and then middle density is 0.35 and high density is zero point 0.5. This is means the higher the density, the higher the contribution of that population to the degree of vote. Something like that. For the population density, we will only try to assign the number for the density weight based on the assumption. But for the area weight, it's quite complex because we will try to do some calculation first before achieve the area weight. So the area weight is actually the ratio between the area of each unit divided by the some area of that unit in one city. Okay, let me show you how it looks like. So for example, this is the blue boundary. It means this is one city in the Illinois County. And here in one city, it can have more than one population density. In one city, of course, it is there are population density, highest population density, middle density, and also low density in one city. And then we will divide the area of one unit for the high density, middle density, and also low density. We will do this calculation respectively, and we will try to calculate the area of one unit and then divide it by the total area of that density in one city. Okay, now let's take example. Now we will try to calculate this point. If you can see here, actually this is show you one unit. The blue point it means one unit. One unit here. We will calculate the area, the area of this blue point, and then we will divide it by the total area. And since this blue point is a high density unit, so we will divide the area of this high density unit point by the total area of high density population in one city. This is the how to calculate the area weight. Okay, now let's take a look how to achieve this. I will open my iDesktop again. Okay, here I already opened my iDesktop. How to achieve that? First, we need to create three new data sets. We need to create three new data sets for the low density, middle, and also the high density. So in the resident intersect, you can browse the attribute table and do the query analysis. We will select the resident intersect data with value 22, and we will create new file. 22 is for low density. So this is the SQL query. So we will only try to we will try to create new density data set that only store value 22. Here, as you can see here, this is only this is store unit that have value 22, refer for the low density. Okay, now we will do the same processing for another class. You can go to the data analysis, SQL, and then now better to clear and write it again, and now select the all field in the resident intersect where the value is 23. Save the result as the middle dense. Check the attribute table, 23. And one more thing is for the 24. We will save the result as the high density. And then click query. Okay, now we have three different density population data, the low density, middle density, and also the high density. Next process is we will add new information in the county dataset. Here, new information in the county dataset that store information of total area of each density, population density in one city. We will try to achieve this one. We will try to achieve the sum area of each population density in one city. Okay, now go back to the iDesktop. So we need to create 3 new fields. Some area of low population density. Please put the double or another type of data here, but for the number, you can use the double instead. Low and then some area for middle. And one more thing is some area for high density, and then click apply. So now we already add 3 new fields, the some area for low density, middle, and also high density. How to update this data is just same like the first process. We will use the that dataset attributes updates, but it will have a different situation. So in the data with attributes offered is the president, is in the prepare data source, and it should be the resident intersect, and target data is county. I mean in the prepare, in the data source with attribute offered, it should be the low density or the middle density or the high density data set. So in the low density data set, it store only unit with value number is 22. And then we will update the county data set based on the low density. Of course, maybe I will show you how it looks like. Okay, this is the distribution of the low density units that already overlay with the county boundary. And then go back to the data and dataset attributes. So we will put the low density as the attributes offered data, and then the target data, it should be the county data set. And in the parameter setting, we will choose intersect because we are trying to keep some information from both of these data set using intersect spatial relation. And in the get value, we will not only assign, but we will do the sum calculation, summary calculation. So we will use the sum instead. And in the field setting, please uncheck the inner system field because we will select the SM area field. So here we will do the calculation. We are trying to do the sum calculation from the low density units that intersected with the county dataset. Okay, so we will check the SM area, and the target field is some area low, since we use the low density in the target in the source data. And we will not check another field, and now I will just click OK. Okay, we will close the map, also the attribute table. Now let's take a look how the result. You can right click in the county and browse the attributes table. So here in the county, we already calculate the sum area of the low density population in each city. So as you can see here, 102 city already has information of the how many is the total area of low population density in each city. Okay, now we will do this process for the rest population, the middle and also the high population density. So you can go to the data and dataset attributes update. Sorry, in here please select the middle one, and the target is county. The spatial relation is intersect. The get value is sum, and in the inner system uncheck, and in the SM area, please choose the sum area middle as the target field. Okay, SM area middle intersect and sum. Now let's click OK. Let's take a look at the result. Okay, great. Now the last one. Okay, now we will calculate the high density population, the sum of the high density population in each country, in each city, sorry, in the Illinois county that has intersect spatial relation, and we will use the sum method for the get value. Make sure if the target field is the sum area high, and then now click OK. And let's take a look at the result. You can right click in the county dataset, and yeah, here we already updated some area high field. Okay, next process is after we already calculate each population density in one city, and next process is we will assign this value. We will assign this value to the resident data, to the resident factor data. So after this, the resident data, each units, I mean something like this, each units, we will assign information of the total area, each population density, something like that. So the how to do that is just the same like the previous one. You can go to the dataset attributes, and in the dataset attributes update, the data with attributes offer should be the county dataset. The county dataset, because the county is have information of total area, each population density in each city, and then the target data is resident intersect, and then the spatial relation is intersect, we will use the intersect instead. And how to get value is assigned, because we only try to assign value from the county to the resident intersect without any other calculation. And in the field setting, we will add only these three new fields. So we will assign the some area low, the some area middle, and also the some area high from the county data set, assign this value to the resident intersect data. So in the target field, since we have not created the field yet, so we just need to click new field, and it will automatically create the new field with name same just like the source field. Okay, and then click OK. So now, while we're waiting the process completed, now I just want to explain to you that this time we already have the information of some area each population density. And after this, we will try to calculate the area weight for each unit. The area weight for each unit. The area weight for each unit is will be obtained from the ratio calculation between the area of each unit divided by the sum area. It's based on the what type of population density it is. So after this, we will try to query on. We will try to only show one population density and then calculate the area weight and do the same process for another population density. Now go back to the iDesktop. It should be 14 seconds. Okay, the process is successfully completed. Now let's take a look the result. You can right click in the resident intersect dataset and then browse its attribute table. So now we already have new information for some area of each population density for every unit, Now, as you can see here, we have more than 3,000 and 30,000, sorry, 330,000 data units, and it's already have information of the some area each category. Okay, now we will calculate the area weight, but before that we need to create the new field. So you can right click on it and then click properties, and then the properties window will appear in the right side. And now please create a new field, namely area weight. And then we also will put information of the population weight. I will abbreviate it only pop weight. And one more thing is for the degree of votes. And then please make sure if the type is the number type, you can just double instead and click apply. Now we have three new fields here: the area, the pop weight, and also the degree. Oh my god, I put the wrong name. Wait, I'm trying to change the field name. Okay, while waiting the process, I will try to explain again about the weight. Okay, the previous slide. Okay, this one. So as you can see in the previous process, I'm making the new field for the area weight, because after this I'm going to calculate the area weight, and then I will also put information for the population density. Just assign the value because it's already determined from the first, that is the zero point 0.5 for the high density population, 0.35 for the middle density, and also 0.15 for the low density. And then I also create a new field, namely the degree, because in the degree field, I will try to calculate this function for each unit. Okay, now the process is already completed. I will go back to the SuperMap iDesktop. Yeah, I already changed into area weight. That takes long time because yeah, I need to change for I need to change the field name for about 300, for more than 300,000 data. Okay, next process. Next process is now let's take a look the attribute table again. Now process is we will do the calculation for area weight and also population weight one by one for three different population density. Now let's start with the lowest one, the low population density. How to do that? Just like the previous one, we need to do the query analysis only to open the records, the unit with value 22 or characterized for the low population density. You can go to the analysis, query, and SQL query. In the SQL query, you can clear it first and select all of the fields in the resident intersect where the value is 22. Now, this time we will not save the results, but only browse the attribute tab and then click query, and it will show here. So this is units with value 22. And now let's calculate the weight. You can update the field. So area weight is in the operation method, since we will try to divide the area of each unit by the total area weight of, since now we select the 22 that characterized for the low density, so we will divide it by the total area of the low population density in each city, in one by one city. Okay, but before that, let me show you. So yeah, we will. So each unit of it already have the area information, and we will divide it. We will divide it by the total area of the low population density. Only the low, because this unit is the low population density. Okay, now let's get start to calculate it. You can update the field. And in the operation method, we will use the double field because we will operate two different fields, which are this one. Oh wait, okay. SM area divided by the sum area of low population density and click apply. Okay, close. We already have the area weight, and then in the population weight, we can update the field. And since in the population weight, we only try to assign the number of the weight. And here, for the low density is 0.15. So we will assign number 0.15 and click apply. Close. Okay, for the degree, we will calculate it later. Now we will do the same process, the area weight calculation and pop weight assigned value for the other population density. So we will close this and go to the analysis SQL query, and we will query the resident intersect where the value is 23, and we will browse the attribute tab, click query, and it will appear the new tab that show only 23 value units. And then in the area weight, we will update it and choose the double field and divide the SM area by the total area of the middle population density because the value is 23, and then click apply. Close. And for the population weight, for the population weight, we will just assign number that is 0.35. Am I right? Wait, yeah, I'm right. 0.35. And then click apply. Close. And now do the same process for the last one. For 24. And the population weight is 0.5. Okay, now go back to the resident intersect attribute table, and now we already calculate the area weight and also the population weight for each unit. And the last process is the degree calculation. So the degree calculation is, we will also use the update field. The degree calculation is, we will put a function because we will use some field more than 2 fields, so we cannot select the double or the single field. We will choose the function instead. And in the operation field, you can, in the function, you can click more and write the function here. What is the function? The function is this one. This one. Okay. So we will multiply, the first one is the total voters multiplied by the different number for Democrats subtract by Republicans. And since this is in the percentage, we will divide by 100 and then multiply it by the population weight and also the area weight. This is the value to calculate the degree, and then click OK. Click apply. And wait until the process finish. It may take time because we handle so many data here, more than 330,000 units. Okay, now the process is finished. Okay, as you can see here, there are negative number and also the positive number. Since we do the subtraction calculation between the Democrats and also the Republicans, so it will give you a negative number. if the number of the Republicans is higher rather than the Democrats, because previously we calculate the difference number from the Democrats and also the Republicans, and we subtract the Democrats by the Republicans, and if the number of the Republicans is higher, of course you will get the negative degree, because negative means that the total Republicans voters in this unit is higher rather than the Democrats, something like that. Okay, now we close this and we will visualize the result. Now open the resident intersect and try to overlay it with the county, data set. Okay, now we already have the resident intersect visualization. And now, since we will try to create the range map visualization for the different parties, for the Democrats and also for the Republicans, so better for us to create two different data sets that store only information for the Republicans voters, dominant Republicans voters, and also dominant Democrats voters. So you can go back to open the attribute table of the resident intersect and do the query analysis to show only the Republicans or the Democrats voters. So we can clear it first and then select the resident intersect data. Select all the fields where the degree is more than 0. More than 0 means that it is dominant Democrat voters. And then save result with name Democrats. And then I will abbreviate it. And then click query. Now the new data set is appear here, the Democrats, and then we will do the same process to create for the Republicans voters. First, we need to query it with condition. With condition where the degree is less than 0. We will not browse the attribute table and keep the result with name Republicans and click query. Wait until the process successfully completed. Okay, now the data is already appear in the under the data source, the Republicans. Now close the attribute table and turn off the layer of the resident intersect and put the Democrats and also the Republicans voters dataset. So this is the distribution of the city with total number of Democrats voters is higher rather than the Republicans, but it's not finished yet. So now we will put the Republicans. Okay. Okay, next process is, as I told you before, we will not only visualize the distribution, which one is city with higher dominant parties, which one is city with higher number of the Democrats voters rather than the Republicans, not that, but we will try to give new visualization in the form of range map that explain to you which area with the number of degree of the voters is peak, that indicates that in that city, in that units, it's already already contribute the area weight and also the population density. Okay, now let's create the thematic map for the Democrats and choose the range map. Okay, we will start with the Democrats one. Okay, in the SuperMap, if you want to do the symbolization, you need to create the thematic map layer first. So that's why I create the thematic map for the Democrats, and also I will create the thematic map for the Republicans layer after this. Okay, start with the Democrats. In the expression, we select the degree and divide it by 1000. This only to make our calculation easier. And in the method, you can select based on your requirement. Okay, this time I will use only equal interval with the number of class is 3. I will turn off the Republicans layer. Okay, commonly the Republicans is characterized by red colors, so I will use red color. And here, okay, better for us to divide it by 10,000. Okay, and then here, since we put the 3 as the range count, so it will give you 3 class only, but you also able to change it based on your requirement. And here I will change the color, maybe better to give more darker color. And I will not give the boundary. Sorry, I forget to remove the boundary. And then also this one, I will remove the boundary. Okay, now we already create the thematic map for the Democrats. So sorry, I think I should make it more lighter. Sorry, my bad. This Democrats is a commonly used blue color. So I will change the color into blue here. And I will make this more darker. Okay, as you can see here, so the darker mean that in this area, the different number of the different number between both of the party is so big, and also there are also uh, contribution from the population density and the area weight. Now we will do the same process for the Republicans. We will create a new thematic map. for the Republicans. And in the expression, we will use degree. We will divide it by 1000 and multiply it by -1. And the color is red. We will use the red instead. And now let's change the style. And remove the boundary. And also this one. And overlay it with county. And better for us to change the county color, you can double click in the county layer and change the color into maybe gray, such as this one. No. The darker is better. And the line color is white. It's still loading to visualize all of the data. Okay, actually, I think the difference color for the Republicans is not quite good. So sorry, I will try to change it again. I will make it more lighter. Okay, let me show you more details. So in this area, the blue means that the Democrat voters in this unit is way higher rather than the others, rather than its surrounding, because of the population distribution, because of the population density, and also the number of votes. And that also happened for the other areas, such as this one for example, this area, such as this one, the thick color, the red here, has the degree of vote way higher rather than the surrounding. And since this is red, means that the Republican voters here is way higher rather than the others because of the population density and also the total number. Okay, the population density, the area weight, and also the total number. Okay, now let's make it more beautiful again. I will add new layer for this map by create a buffer from the county with number 100 and 1500, and the result is this one. And then sorry, one more is for with radius of the buffer is 3000. We will change the order. And change the color. Double click in the layer, and then I will remove the boundary and change the color this one. And for the 3000 meters, I will change okay, and remove the boundary. Okay, now that's all for the maps. Now we already have a map with information, the degree of fault for each unit, for in the Illinois County. So we already do the scoring analysis for some parameters for the population density, population distribution, and also the area, and then multiply it by the main function, that is the total voters, for the total voters, the proportion voters for each unit in the previous process. So that's all for the presentation today. Of course, you can make the maps more beautiful. You can explore more in the symbolization in SuperMap by creating the thematic map, just like the previous process. And then, of course, just like the previous webinar, the previous SMC, you can try it by yourself. You can try all of the processing step by yourself. You can download the material in the link attached in the presentation in the bit.ly/smcweb_material. And please submit your result. Should you already successfully completed this challenge, you can submit your result to the link attached in the presentation also, because participants who submit their result will get certificate from us. And the due date for the submission is next month in the 7th of September 2020. And then that's all for my presentation today. So if you have any other information or question, you can reach us by email. Thank you.
Thank you, Ms. Gandes. That's a really good presentations. Also, thank you for everyone. It was a pleasure being with you today. We appreciate you being here. Today, webinar materials will be uploaded to the link mentioned on the PPT. Also, the recorded session of this webinar will be available on SuperMap YouTube account. As Ms. Gandes mentioned earlier, we prepared the certificate for the participant who submit the task, which is explained details on the submission link. Please visit the link on this PPT, or you can screenshot this announcement. Also, you can wait until the video of this webinar being uploaded on our YouTube account. So thanks again for joining us today, and we will see you next time. Thank you all and have a great day.